Welcome, everyone, to this workshop on building your first CLI hacking tool with AI because it's 2025. So everything has to have AI in it, including this presentation. So the only way to begin is by beginning. So the first thing I want to highlight why this is so incredibly important. 75% of security professionals report that automation reduces the time spent on manual security tasks such as log analysis and vulnerability scanning. There are lots of tasks we do every day that if we knew just a little bit, just a little tiny bit of programming, we could automate parts of our life. I'm not talking about automating ourselves out of a job. I'm talking about being able to be a hero in your workplace and be able to focus on the important things, not the mundane aspects. 60%, 8% of organizations have seen productivity improvements through automating security processes, which helps us focus, as I just said, on critical things like threat analysis and response. And an estimated majority of cybersecurity tools, 40 to 45%, are written in Python. Now, if you've ever tried to take a Python course before, you may have taken 4, 5, 6 of them, and you may get a little bit of the syntax, but you still may not know where to start. And that's where we hope to bridge some of that gap, build useful tools in this workshop. So the agenda for today, we're going to do an overview of the workshop and modules. This is a bit of a mini course. There are 4 modules to it. We'll give you a bit of an introduction to Python for cybersecurity, talk about leveraging Python Fire specifically, which is a great tool for taking your Python functions that already exist, making them command lines literally within 3 seconds. And it's going to be the crux of a lot of what we're going to be doing today. We'll talk about incorporating AI in tool development. Once you know kind of the nuts and bolts of how a CLI or command line application tool is made, we're going to look at how we can take AI and boom, say, hey, AI intern, I want you to write this thing. And as long as we are very specific, we can get code that works pretty much on the first try, with a couple adjustments, even if you don't have a ton of programming knowledge. Then we're going to look at lots of examples. There's going to be lots of times we're going to be switching back and forth between slides and real code examples on the screen. So we'll see a lot of that. But before that, I'll take the 30 seconds, talk about who I am. My name is Brandon S. Keath, founder of the Hacking Lab LLC, company dedicated, basically running my free time to create incredible education content for you all and everyone here. I'm also a senior security engineer. I've been in this field for over 17 plus years. My claim to fame is I got to meet John 7 years ago at B-Sides, Delaware, before he got famous. So that was really cool. I got to meet him in the speaker room. I have 3 master's degrees, a master's in cybersecurity, an MBA in IT management, and actually a master's of education in instructional design. So you'll see a lot of instructional design elements within this workshop and the courses I build. They're very purposeful. And I'm currently working on a master's degree in computer science in AI because it's 2025. You have to have AI. And I specialize in ethical hacking, Python programming, cybersecurity strategy, in compliance. I'm very heavy in AppSec, and that is my main domain. All right, the teaching model, won't spend a lot of time on this, but this is the ethos of how I teach. We're going to tell you why the thing's important. We're going to show real life examples. We're going to then do practical exercises. You're going to apply what you do in the labs or workshops to actual things that can help you in your job or career path. And then we're going to assess via quizzes and other things how well you're doing. So that tell, show, do, apply method is the one used across everything. So without further ado, the only way to learn a new programming language, as Dennis Ritchie said, is by writing programs on itself. What you'll see in this workshop, the module 1 is going to be an introduction to CLI tools, security automation. Module 2, we're going to talk all about your Python fast primer. This is going to be a key aspect. If you've never touched Python before, there is just enough so you can actually get up to speed really quick. So again, if you have never done anything with Python before, you go into the primer, it's going to get you up to speed just enough to get through the workshop. Then after we get through all of that, we'll AI for accelerating tool development. We'll talk about customizing CLI tools. Module 3, you'll actually build your first CLI tool in Python, we'll build it several ways. So you're going to build it with argparse, then you're going to build it with Python Fire, and you'll be able to compare different ways that you can build command line applications. So in your brain, you can kind of connect the dots a little bit and see different ways of doing things and do things your preferred way. What makes sense to you? In module 4, that's where we have specific labs that you can go through. Of course, you can, after taking this workshop, you can build your own tools. You restricted to these labs, but these labs help you along the way of building your first tools that might be valuable. A blue-red team, because we all use Nmap, specifically NetExec or CrapMapExec as it used to be called. So customizing reporting out of that, parsing text files, and then querying Windows event logs with a CLI tool. So those are 3 labs. So with that, what is Python again? Because I already said a lot already. It's a high-level programming language by Fedor von Rossum, and I'm sure I said that wrong, in 1989. So it is a very old programming language, 35, 36 years old. So it's been around a long time and was created to be simplistic, easy to use, and read. And it's now arguably one of the most popular programming languages in the world, especially in cybersecurity. It's dynamic, it's powerful, it's easy to learn and utilize, and you can rapidly build and prototype and deploy applications, especially as we'll see with AI. Now, we couldn't possibly cover everything in Python in this workshop or even in a gigantic course, but this is kind of a spider mapping of the different areas of Python. So we can see applications in cybersecurity, data science, machine learning, AI, web development, variety of tools from version control, a PyCharm, Visual Studio Code, which we'll be using the majority in this workshop. So we'll look at one things we'll think about is Python offensive security use cases. For example, Nmap for scanning, NetExec for credential dumbing, Kerboot for brute forcing, command and control systems, and packet scripts for lateral movement using things like Pretender, Responder. A lot of those things can be automated with Python. You can build tools on top of these tools, and Metasploit there, not used quite as much anymore, but still used in different circles and for niche exploits. So all of those things can be automated when you're utilizing Python. And then defensive use cases, automation, analysis, reporting. Definitely a lot of reporting and analysis, a packet analysis tool like T-Shark or TCP dump, log analysis, data manipulation, automating all kinds of scripts from PowerShell to Bash with Python, threat intel retrieval, network monitoring, all kinds of use cases here. So let's go in, and anyone in the chat, if you have never used Python before, go ahead and put a 0 in the chat. Want to see that light up if you have used it before, but you're still new. 1, and 2 if you're intermediate or above. So fill up the chat, give me an idea of where everyone's at. I'll change a couple things depending on what people say. But we're going to start with what is Python syntax. And syntax is the way that the programming language interprets what we say into what we want the computer to do. It takes it, puts it in a machine language the machine can understand. Now, there's several areas in syntax, just like when we speak in a language, like I'm speaking English right now, that the computer understands. In Python, we have major ones that are not specific to it. Well, that are specific to it, but are specific to a lot of languages, strings, which are things we can read, numbers, floating points, lists, tuples, and dictionaries. And to do that, this is where we have our first hands-on. So if you are in the Visual Studio Code Editor and Workshop, you can follow along. If not, that's perfectly okay. So we're going to look at a couple of different things. Unlike other programming languages, if you've ever done a university course or tried to take a course on C++, we don't need to define our variables before using them. We can immediately assign them, and Python will actually figure out what they are. Now, a great extension that I recommend and use in Visual Studio Code quite often is this one called a REPL. And for those who don't know what REPL stands for, it means read, evaluate, prompt, or no, print, and loop. And what that does is it's just going to show us kind of what we do. Python has a built-in REPL interpreter but I like a REPL because it works in Visual Studio Code. So I'm going to go ahead and hit space so it activates. And we can actually see right here, number equals 5. We actually get an output of all of our variables and what they look like or how Python is interpreting it. So we can actually get a much better idea of what's going on. We can see that this is a number. We can see the floating point, the tuple, and we actually can see the curly braces in here. So this helps us interpret parts of our code, especially if you're new and you're not quite sure what a variable got assigned. This can give you a really good idea. Now, when we talk about programming, typically we will talk about different control structures, right? So typically in any kind of programming class, that will be if then structures, repetition structures, but we don't always talk about sequential. Sequential is the default. If if I run this program, it's going to interpret everything from top to bottom. That is sequential. That is the basic building block. And in Python, unlike other programming languages, we don't have a default class, such as something that says main or something that we're hooking into. We are running everything from the top to bottom. That's how it's going to read, left to right. And that's how we do it. But there's other control structures, such as selection and repetition, that could be very important to us, such as if then statements, one of the most popular areas when we talk about different Python control structures. So this is simple in that if this variable equals this, I want you to do this. And we see this all throughout different areas of programming. It's normally the first thing we learn, and that can look something like this. So we can see, let me get the REPL out of here for a second, right? We have name equals 1, and I can put if name equals 1, it's 1 equals true, or it's 1 equals false, which is the Boolean value that just shows if something is true or false. So this is just an example of how you might use that logic. Simple, simple stuff, but that allows us to control the flow of the program or what we want to do on screen. Our next area is loops, which allows us to take something and we're going to loop through it, right? We can loop through a number of items, or we can keep doing something until a certain thing stops. This allows us to do all kinds of different things, such as looping through lists, looping through data structures in JSON. Very, very powerful when we start utilizing loops in a lot of different ways we can use them. And where is okay, don't have that one. That's fine. Right. So this was the other one. Apologize. Some of these got a little bit away from me. So we can actually see here, here's our example. We can also get input with if statements using the input statement in Python. This is typically how you do it when you first start out. If I do Python example2.py, it will ask me to enter my name. If I type in Brandon, it will say, welcome back, Brandon. If I type in nothing or just another name, it will say, hello, A, nice to meet you, stranger, right? So that's our example of gathering input and then doing something on input. Again, command line applications, we want things to be a little bit more snappy, a little bit more dynamic when we're doing inputs. So we'll look at those areas. And now functions are incredibly important when we talk about how we can simplify and modify our code. Functions allow us to take certain parts of code, wrap it in something that we can then call upon later, either sequentially or through any of our other control structures. And it becomes really valuable in how we develop applications. So here's an example. We have a function. We use the word define in Python. Other programming languages use different things. The idea of functions come from C, C++, the idea of functions, but you see the equivalent in various other programming languages to contain code. So in this case, we're adding two numbers. We're gathering the two numbers from the people. So if we go ahead and we run Python example3.py, we enter our first number, 5, 10. Did not like that. So I have an error here. Oh, I already have it just set to output 5 and 3. My bad in my example. So in any case, we can use this over and over and over again to take our numbers and add them together in any way we want. So that is our function. And you'll start to see this pattern. If you haven't already seen it, everything we do has input, processing. We're going to do something with input that the user gives us, and we're going to output it. And that's going to be a defining area for us as we go forward. But before we get to that, let's talk about libraries. Libraries are amazing. It is other pieces of Python code that we're going to be able to bring in to do certain things. And as cybersecurity people, we don't got a lot of time to do programming because that's not our primary job. So using other people's code is essential. We do that with the import keyword. A lot of times things are stored in Python repositories such as pip, where we can do pip install the name of a certain Python library, and we can then use that in various ways with our code. There's lots of different Python libraries in cybersecurity, from Scapy requests we can use for doing all kinds of different URL calls. Beautiful soap. Packet is used a lot in various hacking areas, like in things like a responder, IPv6, man in the middle attacks, all kinds of things. So here's an example of how we might import something. So we're importing subprocess. It's a library for allowing us to interact with the bash terminal or command or PowerShell terminal if you're in Windows or in command line. So we can actually interact and run different functions. So that is what that library allows us to do. We can see in this, we are parsing using a terminal command. We're running a terminal command. We are grepping the var log auth.log area. And then we're returning that and counting that. So all this program is doing is saying, hey, how many failed password attempts do I have in my auth.log? Let me know what that is. Right. So this is extremely powerful when we have a problem, right? Well, how many failed logins do we have? With just this is like 10 lines of code, we can find out and have something run on an automated process to tell us. Now, something else that we are going to do a lot of, and this is an example that we talk about a lot in this workshop, is parsing data. So we will parse, typically the two things we will parse are strings and lists. So we'll also see lists. Lists are a lot easier for parsing because of a lot of inbuilt things, but sometimes we'll have a list of items, sometimes we'll have a string, and we will probably parse both. I will tell you right now, strings are a lot more memory performant than lists. When you do a string, it's something that's called immutable, which means to the program, it doesn't change from a memory perspective, which means since it can't change after you create it, it's much more performant. Lists take up 4 to 5 times as much RAM or memory to use. Those are some of the differences. The other type we'll talk a lot about is dictionary, which are widely used for mapping key value pairs, such as parsing JSON, cybersecurity tools, and lots of various areas. So here's a quick rundown on JSON basics. Won't cover every area, but the key things are key value pairs. And we'll see lots of examples of those, like here, when we are parsing the vulnerability database or NVD, right? We're looking through for things that are published and comparing different things, being able to parse that via the JavaScript object notation, which is what JSON stands for, gives us a lot of power in what we can do. Now, moving on to this idea. So once we cover kind of all of those basics, I know this was a really fast run through, we can start talking about the syntax. And many of you may have already taken classes on the syntax or looked up Python syntax. Then we can actually look at how do we actually build things. And an oversimplification, but not a bad one, is looking just at these three components: input, processing, output. You're going to take something, it's going to be something from a user, something from a text document, something from an API. You're getting your input from somewhere. You're going to then process that input, do something with it, and you're going to have something return. It's going to do something, whether that's printing a report, running another command, anything. And this becomes really a great pattern for building our scripts, which in cybersecurity, a lot of them only tend to be, 50 to maybe 500 for a lot of daily just automations and reporting and different things. Sometimes they can get a lot bigger, but just being able to do 200 to 500 lines becomes very, very powerful in what you're doing via Python. So we do have in the workshop a little template and an example to help you think through how you might build different applications. So you start with your input. Here's an example. We're going to take an IP address to check, and we're going to look to see if it is in a block list. Now we're pretending this block list is something we might grab via an API call or something via a threat list. And then depending on what comes back, very simple if statement, this IP is on the block list or the IP is clean, right? So there's several different scenarios we could have for something like this, where we're parsing through logs, looking for specific IPs or comparing them to a block list, or maybe we're doing some analysis afterward of a forensic event. Lots of examples where we might use something like this. And with that, we start to look at how we take all of those things together and build command line applications. Now, we have lots of examples in the workshop, but specifically, we're going to focus for this presentation on Python Fire. So what is Python Fire? It's a library that generates command line interfaces from any Python code. It speeds up the processes of converting scripts. So to do it, it's very simple. Pip install Python Fire. Then we import the Fire library. We define our function. This is why it was important to cover functions even a little bit. So in our case, define hello name. We can return that. And if name equals main is just saying, hey, if you run this program with Python, whatever the name of this program is, .py, run this. That's what this is saying. It's saying run this function. Gives us more control over how things are running. So that gives us a lot of power. So let's go ahead and take a look at some examples here. Oh, I did have one other example I did slightly skip over or forgot. So this is an example of the requests library. So import requests, we want to grab information from an IP address, and we're going to parse the JSON format. We are, in this example, we are just parsing the Google IP address. So if we do Python example4.py, we actually see we pull back and parse it in JSON, the IP address information on who is that exists on that IP address. So we can actually see this is Mountain View, California, owned by Google. So just a quick tool for doing that. Here is our template that we had looked at earlier, but we are on, go to the next one. There we go. We're on our Hello Fire application. So we're importing Fire, classic toolfit, kit. We're defining greet, defining add. So we're utilizing this to do a couple of things. So if we just run Python hello fire.py, we can actually see, look at that. We have a command line application and only 11 lines of code, right? And it's bringing back some syntax, tells us, hey, name, gives us a synopsis. We hit, and it tells us our commands we can do, add in greet. So now, come on, why is that? There we go. So now let's go ahead and add 5 and 5. We get 10, and we just do greet. We'll say Brandon, and it'll say hi, Brandon. So we can see that wasn't a lot to make our first application. And then if we look at a more complex example, like our own port scanner, we can see we have a bunch of different functions, right? And we're calling those functions in main. And then if we run that, you can do it, YouTube. There we go. We can actually see there's our scan.py with a bunch of flags, very similar to what you will see in command line applications if you're doing hacking in Kali Linux or doing defensive tasks. Just like any other command line application, we are creating our own with Python Fire very quickly. And to skip that part, because you don't need to see it run, we can see that this very simple port scanner is pulling back information. Now, chances are you're not going to write your own port scanner. That's cool that you can do that, but in most cases, you'll be using Nmap, Rust Scan, or maybe automating some of the output or things that those applications give you. Now that we have all of that context set up, how can we utilize AI to do most of this work for us? And that's really the key question. They often say good systems administrators or IT professionals are lazy. I like to think that we just like to solve a problem so we can get to the next problem to solve. So, how do we describe a common problem we have to AI, treat it like an intern? And how could this problem be solved? But we're not programmers. But if we can be specific, maybe we can get it most of the way there, so we don't have to do a lot of things. So, what should we give the AI? Inputs, right? We talked about our input processing outputs. If we're very specific on those things, I wonder if the AI can follow very similar pattern that we were just talking about to give us different things. So we're going to give it inputs. We'll tell it what we want it to do. The outputs, we'll tell it the flags, and we will specify specifically, hey, use these libraries. So there is our prompt. And we can see, here we go, we're typing in our prompt into ChatGPT 4.0, and it is generating with the libraries we specified a bunch of boilerplate code that surprisingly does a pretty good job in quickly creating different command line applications for us. So by being super specific, we can get ourselves 90% of the way there. There's still some tuning generally, or things may not always come across the way we want, but it's pretty close. It's pretty good, especially when we don't have a lot of time and we're trying to automate something. So in this example, we had 53 lines of code generated. You can see some examples of parsing. Specifically, this code was for, I asked it to parse Nmap XML files, and this was the result, and printed out into a document. So it is using docx, allows it to create things in documents. So it's going to automatically take any output from Nmap and create a Word document report. And of course, we can do a bunch of things to this reporting and template and make it a lot nicer, a lot better. So we can then create all kinds of reports on different things via our command line applications. We can automate our Nessus reports and vulnerability scans to specific hosts, to specific departments. We can create reports. I don't know if you're like me or if you've worked in an environment. I deal with lots of different departments managing tons of vulnerabilities with different teams. So the ability to generate or take information for various teams and help them focus on the vulnerabilities they need to patch or solve can be extremely helpful. So, in summary, Python is a very powerful tool for cybersecurity and automation. Libraries like Python Fire make it super easy, even if you don't have a ton of programming knowledge, to create tools and turn existing Python functions into CLI tools. By the way, that works with any existing Python tools. I had a lot of fun going through existing tools like crap map exec and net exec and just pulling out specific functions that I wanted to turn into more of a command line part of some of those different tools. Maybe net exec's a bad example because it is a command line tool, but you get the point. Any kind of function becomes open game for you. So, and last but not least, the key to building any of these tools is defining the problem. What is the problem you're trying to solve? Every good tool solves a legitimate problem. Once you define that problem, the solution becomes inevitable. You will eventually come up with a solution. So that is the presentation. Have some time for questions, but I hope you guys really enjoy the workshop. There's a lot of content there. We only covered a couple of things. This is just a sampling of a much larger Python for cybersecurity course that the Hacking Lab has coming out in August of 2025. So please, if you like this, check that out if that's something you would be interested in. You can always check out the latest courses and content and things we're doing at thehackinglab.com and our YouTube channel, where we post a lot of free educational content. With that, let's move to, if we have some time, to any questions. I think we have 9 to 8 minutes left. Let me pull up some of one of the streams, see some of the questions. If we have any, we don't.
Hey, Brandon,
Is
just
there?
wanted to pop in. Yeah, because I didn't think that was a question, but I thought it would actually be a pretty good comment to talk about everything with Python as it is, all the libraries and the virtual environments and such. What are your takes
Yeah.
on that, man?
So here's the thing with virtual environments. So especially if anyone for some of the newer Kali updates, right? Virtual environments are so incredibly important because it prevents dependency hell, which is where you have a lot of issues with. Oh, sorry, I thought you were saying something, Anthony. So you have a lot of issues with different dependencies that may coalesce. So the idea behind creating virtual environments is good to learn. We don't cover that super in depth, but yes, typically for every Python application you run, you do want to create a virtual environment where you install all of your libraries. Is it safe to use AI in SOC? That is a great question, Paresh. It really depends, right? If it is locally generated, it's going to be a lot safer because you are controlling the data flow and where the data is. If you are not, then it becomes really suspect. It depends on the data, what articulation agreements you have with that data going to the cloud. A lot of companies are trying to figure that out, whether it's okay for them to send certain personally identifiable information to ChatGPT's cloud, OpenAI, or Gemini, or other areas. That's definitely an ongoing thing that's being discussed in cybersecurity. Does that have anything to do with PyTorch? No. Python Fire, a little bit of background, it was actually created in Google by a team that needed to make their own command line applications, but didn't have a lot of programming experience. They were IT professionals that didn't have a lot. So they wanted a way to quickly create command line applications that were simple. And that is why it was created. So there is actually an equivalent, and we don't talk about this here because it's about Python. There's actually an equivalent in Go too that was also inspired. So if you're looking for even more performant CLI applications and you do any kind of Go programming or you get into that, there is a equivalent over there as well. What's the best way to get ChatGPT, other LLMs to not hallucinate? Honestly, some of the hallucination hasn't been as bad on the programming aspect, excuse me, recently with the newer models. So if you're using things like Claude or ChatGPT 4.0, it's pretty good. What I've seen, especially for programming, if you keep your scripts and applications small, being under 250 lines, it does a pretty good job. If you keep it to one file, it doesn't hallucinate as much. One of the biggest issues that I ran into working with ChatGPT, though, and examining code it gave me is it didn't always give me the most performant code. And one of the interesting issues I got into, I was doing something that would parse very large Nessus files. I was basically creating my own version of PlexTrack for anyone out there who knows that. I was creating kind of a mini version for myself that would parse different vulnerability data. And one of the issues in Python I found was that it took 10 minutes to run. And like I just started talking to ChatGPT. I'm like, why does this take 10 minutes to run? Do I need to go to Go? Do I need to do this in C? It's like, yeah, you could do that, but you could also just use this specific library that compiles down and uses C and will make it run like 1,000 times faster. And I was like, what? So sometimes it's about asking the right questions in our prompts, saying things that are performant, all kinds of things when we're doing some of these programming. Yeah, I used PlexTrack for a long time when I was doing a lot of pen testing. Definitely a shout out to them. They have a great product. Introduce all, yep, clear as possible. It's interesting. Copilot is kind of losing. It depends on who you ask, because different programmers will tell you different things on which success they're having, which with different models. It changes every day. I swear. Return values, absolutely. The more, Roberto, the more information you give, the better. So the more specific in your prompt you can get, like I classify it as your inputs, your processing, your output, your flags. But the more you can give it, the better. I've actually taken classes. I do a lot of video game modding on Nexus for games like Starfield and different ones. And one of the things I found was going in and grabbing the C++ functions behind the scenes and giving it actually helped me, well, helped it analyze and helped me understand how different code works when I'm going and reverse engineering things. So yes, the more you can give, the better. 3.10 versus 3.12. Yeah, there's a lot of features in different Python versions, and you have to be a little careful of what you're doing. The newest version of Python is getting a lot faster, and we're seeing a lot of improvements, but definitely there's some compatibility you got to be. Yeah, token running out of tokens is definitely an issue for sure. As soon as Burp Suite AI came out, it's like I want to spend all the tokens, but then I realize how quickly I run out. Thank you, Chris. That's great feedback. I'm glad it was helpful. Yeah, on LinkedIn you can find me Brandon Dash Keith. So just look it up. I'm definitely there. Encourage you to come follow. I do post things on LinkedIn quite a bit from time to time. All right. Well, definitely, I'm going to be in the Discord for this workshop for anyone that's working through it. If you have any other questions, again, I hope this helped anyone who might just want to give Python a try, maybe in cybersecurity. It really can be a superpower for you. And I hope we get more people in the community programming because it is more accessible than ever.